Welcome to another video. In this video we are going to solve diameter of binary tree problem from the Leetcode. They will give a head to a binary tree and we need to return the maximum. The length of the path between two nodes is represented by the number of edges between them. So we need to return the diameter of the tree. So diameter of the tree is represented by number of edges. So let us say we are at node 1, that is root. Maximum diameter is this path 4, 2, 1 and 3. If we follow this path, there are 3 edges. So one is connecting 4 and 2 and another is connecting 2 and 1 and one more is connecting 1 and 3. So diameter becomes 3. So this can be anything. Even if we don't include the root node, there may be possibility of other lengthy paths. We need to return the maximum path. In the first example itself, there are 2 paths which consists of 3 edges. Consider the second path where 5, 2, 1 and 3. 5 and 2, between 5 and 2 we have 1 edge, and between 1 and 2 we have 1 more, and between 1 and 3 we have 1 more edge. So this is the definition of diameter of a binary tree. We need to return the maximum diameter. This problem can be solved using similar technique that we use to find height of a binary tree. The thing is, when we are at a particular node, we can compute the diameter easily for that particular node by calculating the height of the left subtree and height of the right subtree. If you consider this node 1, the height of the left subtree is 2 and height of the right subtree is 1. So the maximum diameter will be both the heights. We need to add those 2 heights. So there are 3 edges. So to the left we have a height of 2 and to the right we have a height of 1. We will compute the height at each point and we are going to return the maximum diameter. Let us declare a variable to store maximum diameter. We will initialize this variable to 0 and we will write a function to find height. This function will take root as an argument, and if root is null, if not root, then it will return 0. Otherwise what we can do is we can return 1 plus maximum of. So this was the technique behind finding the height of the tree. We will return the maximum between these 2 things. Maximum height of root dot right. But in this problem we need to keep diameter at each point. So instead of directly calculating the height, in between we will compute the height as well. So left height will be equal to find height of root dot left, and right height will be equal to find height of root dot right. So we don't have to compute it again. We can directly use these things: left height and right height. So this is for computing the height of the binary tree. But in between, using the left and right height, we can compute the diameter as well. So we will update the self dot max dia will be equal to maximum of current value at self dot max dia, and at this root our diameter of the tree will be sum of those heights, left height plus right height. This is true because if you consider this first example, to the left at the node 1 we have a left height of 2, and at node 1 we have a right height of 1. So maximum the current diameter at node 1 will become 2 plus 1. Similarly at node 2 we have a left height of 1 and a right height of 1. So our diameter will become 1 plus 1, 2. At each node we are going to update this max dia if we have a diameter which is larger than the previous value. This is the definition of the function, and we need to call this function so that our max dia gets updated. So we will call this function find height of root, and then we are going to return self.maxDia. Let us submit this solution and check whether it passes the initial test cases. Yes, as you can see here, this solution is passing the initial test cases. Let us submit this solution and check whether it passes all the test cases. Yes, as you can see here, this solution is passing all the test cases. If you are interested in learning more about other data structures and algorithm related problems, you can check out other videos from my channel. Thanks for watching this video.